Okay, hopefully you've worked on these problems before you found this answer key video. Let's look at number 1. So help me out. I see a root there. Which root is it? Good, it's the square root. And I'm solving for the variable p. Happens to be under the square root, so what are we going to do? Yeah, we're going to have to get rid of the root of 2 by taking the power of 2. So I'm going to raise both sides to the power of 2, right? Okay. So on the left side, yeah, we just get 6p minus 5. And on the right, 25. Excellent. Okay, very simple equation to solve. Tell me what to do next. Add 5. So we have 6p equals 30. And then you have p equals 5. Excellent. But remember, yeah, you got to check your answer. You need to make sure your answer works, that it doesn't like blow things up, right? Okay, so if I check it here and I plug it in, I have 6 times 5 and then minus 5, and it's supposed to be equal to negative 5. Well, multiplication first. 6 times 5 is 30. And you're taking the square root of 30 minus 5, which is 25. And the square root of 25 is? You're like, hey, wait. Yeah, the square root of 25 is 5. Remember, there's an imaginary plus sign in front of here. A negative 5 and a positive 5 don't equal each other. This answer isn't going to work. Like, wait, I did everything. You're right, you did everything correctly. In the lecture video problem, when we plugged that 6 in, we ended up with taking the square root of 16, which equaled 4. So it all worked nice and neat in that video. In this one, you did everything correctly, but it doesn't work. Because check it out. This square root has a little imaginary plus sign in front of it. And you're trying to take the square root of something with a plus sign in front, and it's equaling a negative? How can a positive equal a negative? So right at the get-go, you're like, oh my gosh, it failed right from the start. It failed right from the start. You can't take the square root of a number wanting a positive answer and it equaling a negative answer. There's no solution to this particular problem. It's the way it goes. You're sophisticated now. Good? Okay. Let's look at problem 2. Okay, what are we solving for? Yeah, we're solving for x. I know x is located under the square root, and you're right, that is a square root. But here's the deal. Isn't there something else on the same side as the x not under the square root? Because this whole thing has to stay together because this whole thing is under the root. Yeah, there's that 2. It's not under the root. It's not an x. So are you going to keep it on the same side? Nope. Let's scoot it over. So we end up with taking the square root of 4x plus 21, and that equals 3. And gratefully, it's a positive, right? It's not a negative. So we know things are going to work out here. Okay, I'm solving for x. X is under the root. There's nothing else on the same side besides the root. What are you going to do? Raise it to the power of 2 because it's to the root of 2. And yes, we end up with 4x plus 21 equaling 9. Very good. And then minus 21 on both sides. Okay. So when you minus 21 on both sides, yeah, you end up with a negative 12, and x equals negative 3. And you're like, wait. I have a negative answer. Yeah, you do. It's okay, hold on. Let's check it out. So, square root of what? 4 times negative 3 plus 21. Whoops. Doesn't help to transpose the numbers, does it? And then you'll add 2, and it's supposed to equal 5. So, 4 times negative 3, negative 12. Negative 12 plus 21, 9. So you end up taking the square root of 9 here, which gratefully I can take the square root of 9. That is 3 plus the 2. Yay! Check. Just because your answer is negative doesn't mean it doesn't work. This worked. Over here, my answer was positive and it didn't work. Good? Okay. Number 3. What'd you guys do? I have the third root on both sides. Gratefully, it's the same root on both sides. If it's not, we got something else to do. But we're good here. So what are you going to do? Yeah, if it's a third root, then I'm going to take the third power. Lovely. So we end up with 4x plus 3 equaling 2x minus 9. Great. Move the x's to one side. How about we move them to the left? So you have 2x plus 3 equals minus 9. Move the 3 to the right. So you have 2x equals negative 12, which means you have x equals negative 6. Oh, you're like, we have to check it. We should, to make sure we have the same answer on both sides. But the great thing about a cubed root is I'm allowed to get a negative answer, aren't I? We'll check it anyway, just to make sure. It's not a bad idea. With the cubed roots. The square roots, you always need to check the answer. The cubed root, not so much because I'm allowed to get a negative answer. Okay, so 4 times negative 6 plus 3. That's supposed to equal the cubed root of 2 times negative 6 plus, minus 9. Sorry, I'm running out of a little bit of board space here. All right. We have negative 24 plus 3. And the cubed root of, what is that? Negative 12 minus 9. Let me get rid of this and make it a minus, because we have a minus. So we have the cubed root of a negative 21 equals the cubed root of a negative 21. Yay! And yeah, that's not a perfect cube root, so we need a calculator to actually get that answer. And I don't have my calculator on me, and I'm not concerned in this case what the cube root of negative 21 is. Point is, I got the same thing on both sides. So the answer of x equals negative 6 checks. Good? Okay, hopefully this made sense. Catch you on the flip side.